Hello viewers, welcome to the course on agronomy, and we will study the basic principle of crop production, wherein the first we have studied already the effect of the environment, climate, and now today we will study about the soil and soil preparation. It is the most, as we have mentioned here, that cultivation of crop involves the several activities undertaken by the farmers over a period of time. These activities or tasks are referred to as agriculture practices. They are preparation of the soil, sowing, adding manure and fertilizer, irrigation, protecting farm weeds, harvesting, storage. The effect of the production varies by the environmental factors, and these are now today we will mainly concern on the preparation of the soil and sowing. The crop growth is influenced by aerial and soil environment. Suitable environment is necessary for better germination, growth and yield of crops. Aerial environment is less amenable, means we cannot modify the aerial environment. We can't change the temperature, we can't change the rainfall, we can't change the wind speed. However, it can be slightly adjusted by the plant population, by removal of the weeds, the light competition can be avoided, we can fluctuate moderately the environmental factor. But the soil factor can be easily modified. So, soil environment can be altered substantially by tillage, fertilizer application and irrigation facilities, free aeration, reducing the mechanical resistance and providing adequate nutrient and water. So, it means that the aerial environment factors cannot be changed, but the soil environment can easily be modified. Soil environment can be studied under the physical, chemical and biological environment. Soil has a different characteristics like the physical character, like chemical character and also the biological characters. The favorable physical environment for proper crop growth is deep soil without hard layer or high water table, so that crop can exploit larger soil volume. The soil has to contain higher water holding capacity, proper aeration and less soil strength or mechanical resistance. The favorable soil chemical environment is higher nutrient availability. The biological environment consists of favorable organism in the soil. There are lot of the microorganisms are there, macro and microorganisms. They change the environment of the soil. So, they have a very important role, and through understanding of the soil properties is essential for its management for higher productivity. Now, the physical environment of the soil. Soil physical environment is controlled by soil characters like texture, structure, aeration, water, mechanical resistance and depth of soil. The soil texture. The soil texture refers to the relative percentage of the sand, silt and clay in a soil or relative proportion of the particles, or it is the relative percentage by weight of the three soil separates with sand, silt and clay, or simple refers to the size of soil particle or size distribution of the soil particles. You can see here that soil contains mainly the three components, the clay, sand and silt, and their arrangement, particle arrangement, it forms the soil, provides the physical environment and also provide the mechanical strength to the soil. Now, where does soil comes from? From where, how the soil is forms? The soil comes from the rocks, minerals and organic matter. These are the three main components. We can see here that the bedrocks begin to disintegrate The soil is formed from the bedrocks only. So, during the rains or the weathering, because of the weathering, the soil start forming from the rocks. The second slide you can see here that the organic matter, once the soil is formed small, then some plants like lichen, algae, some small parts will come, plants will come, and they start forming some organic matter, and this way some organic matter. So, organic material facilitate the disintegration of the again the rocks. And then third slide you can just see here that because of the growth of the plants, some plants roots die, some leaf fall down, stem and all the things, and they form a humus. So, mineral fragments and organic matter, it is the third one which shows the humus. Horizon A, now you can see from first slide to the third slide, there is a dark color, means soil buildup started, and then the lower layer, the parent material, sea horizons and the bedrocks are there. And if you go on the fourth slide, here we can see the organic contents are more, organic matter are more, horizon depth is A horizon is increases, and then B horizon also the soil formation start, and where the roots have gone there, and this way we can see the developed soil supports the thick vegetation. So, this is the structure how the soil is formed. You can just see this diagrammatic way, the A horizon, E horizon, B horizon, C horizon, all. So, topsoil, how the topsoils are formed from the C to D, the bedrocks are there. Then what are the factors that makes the soil, how the soil is formed? For that purpose, you can see that formation of the soil, it may takes long time. It takes 1000 years to the 10,000 years or more than that year. So, that is the very important that we should avoid the soil erosion, we should try to preserve the soil, it takes long time. Lay of the land, it totally depends on the topography of the soil, what types of land is there, topography, rocks. So, the slopey, plain, all this depends on the, then third is the living organism, because once your soil is formed, then some microbes, some small, they help in the soil preparation. So, animals and the plants play a very important, and then is the climate is the main, where the hot, cold, wind and rains, all these combines together, they helps in the weathering of the rocks and forms the soil. Then parent material like the rocks and the minerals. So, how we can get the soil I just mentioned here. What are the main components of the soil? If we see the soil, the mineral material, air, water and organic matter, these are the main component of any soil. And you can just see here that air filled, if there is a good soil, then 25% is the air in the soil, which is very essential. It provides the oxygen to the plants and to help in the root this respiration. And then water filled pores, because if the soil is more porous, then the water holding capacity, water will be more, and the plant roots can take lot of water from that one. And then rest is this soil solid, and soil solids, it contributes 50%. It is the mother bedrocks that helps making the soil, and these mineral matters, the mother material that contains 45% minerals and 5% of the organic material. Remaining I have already mentioned 20 to 30% air and the water 20 to 30. So, this is the soil component just. Then if we see that I mentioned that the clay, sand and silt, these are the three main components. If you see the soil structure microscopically, if you see this sand structure, then it is the biggest one. Then silt is the smaller, and the clay particle are the smallest one. So, these particles I have mentioned here. Now, you can see the size of these three, that the sand size is 2 to 0.5 millimeter, the silt is 0.5 to 0.002 millimeter, and clay is the smallest, lesser than the 0.002 millimeter. So, you can see clay is always in the form of the plates. So, this is the structure of, we can see microscopically to them. Then sand. Now, we detail comes to the sand, usually consists of the quartz, but may also contains the fragments of the feldspar, mica and occasionally heavy minerals with zircon, tourmaline and the hornblende. Has uniform dimension, mostly the soil structure, the sand, they have a uniform grain size, can be represented as a spherical. As we have seen in the earlier photographs, it is a spherical in the form, not necessarily smooth and has a jagged surface. Sand group includes all soils in which the sand separates make up at least 70%. When we talk about the pure sand, then maybe it is more than 90%, 70 to 90%, but when we call it say sandy soil, sandy loam, sandy clay loam, all these different depends upon the combinations of sand, clay and silt. So, here we see that if I talk about the sand, then it is 70% it contributes maximum to the soil, and then clay particles are 15% or less of the material by weight. The properties of such soils are therefore characteristically those of the sand in contrast to the stickers nature of the clay. Two specific textural classes are recognized in this group, sandy and loamy sand. Although in practice two subclasses are also used, loamy fine sand and loamy very fine sand. So, here if you look that if your sand is more than 70%, then water holding capacity will be low, because it is more porous, water can go very deep. Then we come to the second, the silt. The silt is a small particle, we have seen that. Then particle size intermediate between the sand and the clay. Since the size is smaller, the surface area is more coated with the clay, has the physicochemical properties as that of the clay to limited extent. Sand and silt form the skeleton of the soil. If you talk about the soil, then they form sand and silt form the skeleton. The silt group includes the soil with at least 80% silt. Silt content is very high and 12% of the or less than 12% clay. Naturally, the properties of this group are dominated by those of the silt. Only one textural class, silt, is included in this group. If you see that in the silt, the water holding capacity is more, but available to the plants is very low. So, now we come to the third group, the clay. Particle size is less than 0.002 millimeter. They are always in the plate like structure or the maybe the needle like in shape, belongs to the aluminosilicate group of the minerals. Here we can get more of the aluminum and the silica there. Sometimes considerable concentration of the fine particles which does not belongs to the aluminosilicates. Maybe they contains the iron oxide and calcium carbonate. These are secondary minerals derived from the primary minerals in the rock. Always consider clay is the secondary minerals, and therefore, they are known as the flesh of the soil. Knowledge on the texture is important. It is a guide to the value of the land. If we have a knowledge that the what type of the soil is there, then accordingly we can suggest which crop is to be taken, and we can also assess the mechanical properties of the soil. So, texture is the most important here. Land use capability and method of soil management depends on the texture. We have classified, there are 6 types of the land use systems earlier, and up to class 4, 1 to 4, they are good for the cultivation, and from class 5 to class 7, they are not good for the cultivation of the crops. So, therefore, texture is very important for any cultivation of the crops. To be designated clay is soil must contains at least 35% of the clay separate, and in most cases not less than 40%. In such soil, the characteristics of the clay separates are distinctly dominant and the class name are clay, sandy clay and silty clay. Sandy clay may contains more sand than the clay. Likewise, the silt contents of the silty clay usually exceed clay fractions. Soil structure. Primary soil particles, sand, silt, clay are usually grouped together in the form of the aggregates. Now, the aggregates, the arrangement of the primary particles and their aggregates into certain defined pattern is called the soil structure. Soil structure is an important soil property which influences the soil environment through its effect on the amount and size of the pore space, water holding capacity, availability of the plant nutrient and growth of the microorganism. Soil structure controls the amount of water and air present in the soil. So, therefore, soil structure plays a very important role. Now, we see here that there are four principal form of the soil structure, the plate like platey. In this type, the aggregates are arranged in relatively thin horizontal plates or the leaflets. The horizontal axis or the dimensions are larger than the vertical axis. When the units or the layer are thick, they are called the platey. Then platey structure is most noticeable in the surface layer of the virgin soil. If we take the virgin soil, then we can see the structure of the soil. So, it is always unused soil lying ideally long for a long period, then we see the virgin soil, but may be present in the subsoil. This type is inherited from the parent material, especially by the action of the water or the ice. Prism like structure. The vertical axis is more developed than the horizontal, giving a pillar like shape, vary in length from 1 to 10 centimeter, commonly occur in subsoil horizons of the arid and semi-arid region. When the tops are rounded, the structure is termed as a columnar. When the tops are flat, plain, level and clear cut prismatic. Then block like. All three dimensions are about the same size. The aggregates have been reduced to the blocks irregularly 6 faced with their 3 dimensions more or less equal. When the faces are flat and distinct and the edges are sharp angular, the structure is named as angular blocky. When the faces and edges are mainly rounded, it is called the subangular blocky. These types usually are confined to the subsoil and characteristics have much to do with soil drainage, aeration and root penetration. Spheroid, sphere like. All rounded aggregates, pads may be placed in this category, not exceeding an inch in a diameter. These rounded complexes usually loosely arranged and radially separated. When wetted, the intervening space generally are not closed so radially by swelling as may be the case with a blocky structural conditions. Therefore, in sphere like structure, infiltration and percolation and aeration are not affected by wetting of the soil, because the pore size they are bigger. So, the water just go very deep, so infiltration is not affected. The aggregates of this group are usually termed as granular, which are relatively less porous. When the granules are very porous, it is termed as a crumbs. This is specific to the surface soil, particularly high in organic matter grassland soils. Now, we can see the through this figure, this which I have mentioned here, the granular type, the columnar types, the blocky types, the platy types, you can just see here the plates like, the prismatic like, and then the single grain type. So, all type I have explained you, that you can understand from this figure. Now, the importance of the structure. Soil structure influenced rather indirectly by the formation of an array of the pores of various shapes and size. These pores are controlling factor governing the water, air and temperature in the soil. Why the structure is important? Because the pore size, which is very important, because that holds the water as well as the air. Therefore, they play very important role. The role of soil structure in relation to the plant growth. Soil structure influences the amount and the nature of the porosity. The structure controls the amount of the water and air present in the soil. Not only the amount of water and air depends on the soil structure, but their movement and circulation are also controlled by the soil structure. So, soil structure plays a very important. If your soil is hard, crust is there, then the root development will be very poor, water availability will be poor, so aeration will be poor. So, that is why structure, it affects the tillage practices, most important. If the soil is very hard, then it is very difficult to go simple tillage activities, then you have to use the heavy machinery for breakdown of the soil. So, structure controls runoff and erosion. Platy structure normally hinders free drainage, whereas spare like structure, granular and crumbly, helps in the drainage. If your soil is flat, then what happens that whatever the rains comes, it will go flow down, water will not go deep. So, that is why the platy structure will not permit the water to go inside, and then crumbly and the granular structure provides optimum infiltration, water holding capacity, aeration and drainage. It also provides good habitat for the microorganism and supply of the nutrients. Plant roots and germinating seeds required sufficient air and oxygen. Why we have studied the soil structure, soil characteristics? Because if you grow the crops, then the germination of the seeds totally depends on the types of the soil. So, therefore, the germination requires sufficient air and the oxygen for respiration. Bacterial activity also depends upon the supply of the water and air in the soil. Soil conditions and characteristics such as water movement, heat transfer, aeration and porosity are much influenced by the structure. In fact, the important physical changes imposed by the farmer in plowing, cultivating, draining, liming and manuring his land are structural rather than the textural. Means lime, you have to add some lime, you have to add some fertilizer, farmyard manure and other things. It totally depends on the structure rather than the texture. Now, we can just see the texture of the soil. We have classified the different on the composition of these sand, clay and silt. Different groups are classified. These sand, if I talk about only the sand, then it means it is 80 to 100% may be the sand, the silt is 0 to 20% and clay is also 0 to 20%. Then if I ask about said that the sandy loam soil, it means 50 to 80% sand, 0 to 50% silt, 0 to 20% clay. Loam soil means it contains more of the silt and clay, soil is sand is 30 to 50%. Silt loam, then the silt contents is more than 50 to, it range from 50 to 100% and soil is 0 to 50%. clay is 20%. Sandy clay loam means 50 to 80% sand, silt is 0 to 30 and clay is 20 to 30%. Silty clay loam 0 to 30% sand, 50 to 80% silt and 20 to 30% clay. Then clay loam 20 to 50% sand, 20 to 50% silt and 20 to 30% clay. Sandy clay 50 to 70% sand, 0 to 20% silt and 30 to 50% clay. Silty clay 0 to 20 sand, 50 to 70% silt and 30 to 50% clay, and clay only, then 0 to 50% sand, 0 to 50% silt and 30 to 100% clay. It means why we have given the soil texture group here. If this a person agronomist, he knows that yes, such type of the soil is there, then he can by simple nomenclature of this texture, he can see that yes, it is rich in clay or it is rich in the sand or it is rich in the silt. So, this is the simple classification. We have studied the physical environment of the soil. Now, we see the chemical environment of the soil. The soil chemical environment is dynamic. The nutrient transformation and its availability in the soil depends on the pH, clay minerals, cations and anion exchange capacity. Soil pH, pH is defined as the negative logarithm of the hydrogen ion activity. The pH of a soil indicates its acidity and the alkalinity. The pH influences the nutrient availability, soil physical conditions and plant growth. Optimum pH range of the availability of the different nutrients. The nutrients are like nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, iron, manganese, boron, copper, zinc, molybdenum. All these availability to the plants depends on the pH, and if you see that the nitrogen availability range from 6 to 8 pH, phosphorus from 6.5 to 7.5, potassium 6.6 to 7.5, sulfur 6 and above, calcium and magnesium 7 and 8.5. Means that if the calcium is more, then we can see the pH value is more. The iron is available at 6 and below, manganese M 5 to 6.5 and boron, copper, zinc 5 to 7. So, you can just see here that if your soil is acidic, the pH range is less. So, it is less than the 5. So, that is why iron, Mn, boron, copper, zinc is available at the low pH value. Which crops can grow in which of the pH value? The rice 4 to 6, rice can grow in acidic soil. Wheat 6 to 7.5, sorghum 6 to 7.5, maize 6 to 7.5, barley 6 to 7.5, millets 5 to 6.5, oat 5 to 7.5, soybean 5 to 5.7, pea 5 to 5.5 to 7, sugarcane 6 to 7.5, cotton 5 to 6.5, potato 5 to 5.5 and tea 4 to 6. So, that indicates that if your pH is acidic, lower range, then which crops can be grown in the acidic soil? If your pH is higher, you can grow the which crops. Here today we have studied about the soil formation, how the soil is formed and what is the soil structure, soil physical and chemical structure we have studied, and we have also studied about the soil, different types of the soil, the clay loam, sandy loam, silty loam, all such type of the soil we have explained, and that is why is the soil is the most important, because soil plays a very important for the growth of the any crops or any plants, and which is say can be modified according to our desire, whereas the environment cannot be modified, simply slightly modification we can do it, but in the soil, if the soil is very hard, we can through the tillage operation we can loosen the soil. So, and then the soil structure completely depends on the rocks where it is formed and the structure how they are arranged, so that accordingly we can modify and do the soil this treatment by application of the fertilizer, by application of the water, and application of the soil working, tilting of that one. So, that helps in the production of the crops, and that is why we have seen here that the soil contains 25% of the air, 25% of the water, and then 50% of the minerals and the organic material. Thank you.